Now this is what we call coordinate geometry. That involves graphing and all that, okay? For instance, a graph has two axes. The vertical one is what we call the y. The horizontal one is what we call the x. The y has positive side going up, negative side going down. That is for y. So you have positive y and negative y, if you like. Did you get that? Also, the x has positive side going to the right and negative side going to the left. So you have positive x and negative x. I hope you're still listening. Okay, so if I dot a point here, for instance, the coordinate of this point is its position on x and its position on y. So let me call it point A. What is position on x and what is position on y? What's the position of this point I dotted here on x? And what is its position on y? Go ahead. What is the position of this point I dotted here on x? And then what is its position on y?
6 minus 6.
Okay, its position on x is 6, right? Now what about its position on y? You trace it to y to get its position on y.
Oh, on the opposite side. Oh, 4.
So the coordinate is 4, comma 6. You mentioned the x first and then the y.
Yeah, but the x was 6, so
Oh, sorry,
6.
I made a mistake. 6, comma y, 6, comma 4. 6, 6, comma 4. Because you mentioned x first and then y later. X, comma y. Okay, give me the coordinate of this point. I'm going to call it B. Give me the coordinate of this B.
13.
Okay,
oh no.
yeah, you're
Not
right.
13. 13,
Comma,
9.
comma 9, that's correct. On x is on 13, on 13th, and then on y is on 9. Okay, give me the coordinate of this point. I'm going to call it C.
Minus 7, 3.
Minus 7, then comma 3. It's on minus 7 on x, that's here, and 3 on y. Okay, give me the coordinate of this point. I'm going to call it D.
0. 0. 0. 1.
I mean here. It's 0 on x and 0 on y.
0, 0.
Okay, so that's 0, 0. 0, 0 is also called origin. Fine, maybe give me the coordinate of this point. I'm going to call it F.
Minus 6.
Are you sure? Is it up to... Okay, yeah, minus 6 and
minus 5.
and minus 5. That's fantastic. You just need to tell me something here, and I think we can look at this later. See this line? Line AB. Can you see line AB? There's something we call slope or gradient. Slope or gradient of AB. This is how to get it. You do y2 minus y1 over x2 minus x1. It's easy. Very, very easy. Which is like rise over run. What I mean by rise over run, you do how much it its height and then its width. See the height? So let me draw it again. The height against the width. That's rise over run. The height is rise. Rise. The width is run. So gradient, you can also call gradient as rise over run. Rise over run, right? So what it is height, what it is width for that line AB? You get the height here to here, and then the width here to here. So rise over run. What's the height?
The height is 13.9.
13.9. Good. Is it 13.9 the height? This is the. I mean the height is the distance from here to here. Watch. See the way what I'm doing.
Yeah.
That's 1, 2, 3, 4, 5. The 1, 2, 3, 4, 5. That's how high it is. Did you see that? 1, 2, 3, 4, 5.
Oh, 5.
What's the width?
5.9.
The width is 1, 2, 3, 4, 5, 6, 7.
Wait, I can't see you drawing.
Oh, okay. Your internet is affecting it. Okay, but did you just see what I did now?
Yeah.
1, 2, 3, 4, 5, 6, 7.
Oh, I can't. 1, 2, 3.
It's counting now.
7.
Did you see that?
That was. That was 8.
Is it up to 8? No, it's the space. 1, 2, 3, 4, 5, 6, 7. 7 spaces. So it's over 7. 5 over 7 is what we call the gradient or slope, and is usually presented with m. So slope or gradient, or which is m, is 5 over 7. It's very easy. Can you do this one so that we will appreciate the work done? Let me see this one very quickly. Look at this. Let me draw this one. Okay, no, it looks a bit. It's going to affect that work. Let me do it separately. Let me do it differently. Let me do something like this. Just a moment. As it's shown at your end, the blue line.
Yeah.
So you also do the rise over the run. So the gradient for this that line is what?
1, 2, 3, 4, 5, 6, 7, 8, 9.
Is it 9? Let me confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes.
12, and then 9 to 12.
That's 9 over. That's for the rise. What's the run?
12.
1, 2, 3, 4, 5. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's correct. 9 over 12. Or you can say 3 over 4. That's a gradient. Rise over run. That's the simple way to do this. It's not difficult, okay? You can even do that by doing y2 minus y1 over x2 minus x1. What I simply mean is, like this one becomes y2. This one becomes, sorry, I didn't put it properly. This one becomes x2. This is x1. Oh my goodness. x2, y2. x1, y1. You will get the same answer. Finally, I just want to show you this. You will get the same answer if you do it like this. If you apply this formula, read it out.
Read
out what I circled.
Y2 x2 minus y1 over x2 minus x1.
If you do that, you will get the same answer. What I mean is the one part you call it x2 and y2. The other part you call it x1 and y1. And just put their values. Like in this case, this y2, what would you have written here? For y2.
13.
No, see what is y2. See the one that represents y2.
9.
So I would have written 9 there. So you get the same answer. You see 9 minus. For y1, what would you have written for y1? See,
4.
4, yeah, exactly. So 9 minus 4. Now for x2, what would you have written for x2?
13.
13. What would you have written for x1?
6.
By the way, x2 is 13, x1 is 6. So it's 6. You would have written 6. Check, you will get the same answer. What is 9 minus 4?
What's what?
Check now, what's 9 minus 4?
5.
Is that not the same 5 we got?
Mm-hmm.
What is 13 minus 6?
7.
7. So the slope is still 5 over 7. If you do the same thing here, you will get the same answer.
Mm-hmm.
That's basically it. The only thing you need to know, need to know is if the line is sloping downwards like this, the slope will have a negative value. Did you see what I just showed here?
Mm-hmm.
Negative slope, because it's sloping downward, negative. But if it is sloping upwards like this, if the line is running up, climbing, it will have a positive slope. This one is positive slope. You know, plus is for positive, minus is negative. Do you know?
Mm-hmm.
Let me just, this is the very last thing I'm going to do, and then you see it. Watch this. I'm going to show you very, very quickly, and that's it. I said if the line is running down, like descending, the answer will carry a minus. If the line is going up, the answer will carry a plus. So just watch it. Let me show you. Let me show you with this one. Let me show you with this one. Are you ready? Okay. Let me show you with this one, and then that will be it. Show you with this one. This particular line now, what's the rise? Let's count.
1, 2, 3, 4,
1,
5.
2, 3, 4, 5. The rise is 5. The rise is 5. What's the run? Let's count the run. 1, 2, 3, 4, 5, 6, 7, 8, 9. The run is 9. So that means the slope will be.
Hello?
Yes, can you hear me? Yeah, the slope for that one will be 5 over 9. So slope here is. Did you hear me? Hello? The slope there will be 5 over 9. Slope will be 5 over 9, which is rise, the height over the run, 9. But we're going to add a minus because it's sloping downwards. You know, so it will have a minus. The slope is equal to. Can you see what I'm doing? Can you see what I'm doing? And of course, finally this one, you will see how that plays out here. Let me show you this one. The same thing. This is it. You also have the rise, 1, 2, 3, 4. Run, 1, 2, 3, 4, 5. Okay, rise is 4. Run is 5. So the slope for this other one will be, the slope is simply 4/5, but it's going to have a plus because it is sloping upwards. If it is going down, I said it will carry a minus. If it is going up, it will carry a plus. The answer will have a plus. That's all. That's all. So like this one that is sloping up will carry a plus. A plus. If it is going down, a minus. So you just do rise over run and all that. So it says the line AB passes through point A and this point. The gradient of AB is 5. Work out the value of K. Alright. Gradient is changing Y by changing X. So 5 is 6 minus K. Why did you say 6 minus K? Gradient is changing Y. Oh, see how a simple mistake like this can read so much.
Do it again.
Yes, please be careful. I'm going to erase all of this. It's a beautiful, fantastic work you've done. Sorry, you don't have a choice. You have to erase all. So gradient 5 is equal to K minus what? You're making the mistake again.
Oh, wait.
Oh, no wonder. It's the way you expressed it. I can see. This is where you're running into a problem. A coordinate is x, y, not x, x. So this is actually x1, y1.
Oh.
Yes. And the other one is x2, y2. So that's where the problem started from.
So would it be K minus 1?
Exactly, K minus 1. So K minus 1. So 5, which is the gradient, is K minus 1. That's y2 minus y1 over x2 minus x1, which is 6 minus 2. That's correct. Okay, let me just use a different color for this thing. Next time when you're doing it, okay, so that it doesn't look like you're multiplying the denominator. Put it at the top, times 4 times 4. Are you serious? Okay, K plus 1, yes. Because the 4 will cancel out this 4. When you multiply both sides, from here, you multiply both sides by 4. Let me write it down. All right, so k is minus 1, k is 19.
Yeah.
All right, that's cool. Both side by 4, you have 20 equal to k plus 1. You subtract 1 from both sides, you have k is equal to 19. Okay.